Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study PN junctions. Now, what a term PN junction means? Let me draw a single diagram here. Consider this is a semiconductor plate and I am doping it with P-type impurity. And I am doping a certain part of this with N-type impurity. Now, if I am cutting this portion and drawing it here, what you will see, this is the P section and this is the N section. And layer which is dividing P to N section is considered as junction. Okay, so this is the simple term PN junction means. Now, from this particular material, we can cut, so many PN junctions. So, if this is a very big plate and if I am doping it with P type or N type, so many PN junction I am creating from this plate. So, this is one part of that. Okay, now let us discuss the working principle of this PN junction in detail. So, this is the PN junction, and if this is P side, we know that holes are in majority, and if this is N side, electron are in majority. Okay, now we know that they both have different polarities. This is positive and this is negative. So, they both attract each other. Negative polarities or positive polarity attract each other. So, these electrons try to penetrate this junction and come to this place. And these holes try to penetrate the junction and trying to come to this place, but in between they will diffuse with electrons. So, this electron and hole recombine here and neutral and follow the charge, neutrality charge here. So, again this positive negative neutral charge, positive negative neutral charge, positive negative neutral charge. So, what is happening due to this process? A layer is formed. Here a layer is formed. Let's say this is the distance d and a layer is formed where neutral charges are inside. It means these charges which are inside, they are neutral in form. So, if they are neutral, I draw it with empty space. So, we consider this as depletion layer. Depletion layer. Now, what a depletion layer means that electron deplete holes completely, means electron ने hole को पूरा खत्म कर दिया. This thing is that. So, here the neutral charge is there. Electron depleted the hole. Electron depleted the hole and this region is empty, which is considered as depletion layer. This layer acts as an insulator also. Now, what will happen? See, this is not the whole picture. What will happen? If this electron loses its potential, so a positive polarity will attain in this place. Why so? Because this electron here, this electron here recombine with the hole inside this layer. So, a positive charge will increase in this side and similarly a negative charge will increase in this side. So, what is happening? Positive and negative charge are there. So, they are creating an electric field in this direction. Electric field always we consider from positive to negative direction. So, electric field is created here. So, due to the electric field, a voltage will create here. So, V is nothing but E into D. D we already mentioned that this distance is D. So, a voltage or a V equal to ED will create here. This voltage is considered as barrier voltage. Barrier voltage. Now, what this barrier voltage means? Now, this barrier voltage, what is happening here? In first time, they diffuse or recombining in this region and the region is empty. After that, positive and negative polarities are, created and the electric field created. But second time, if this electron try to, penetrate this layer and jump here, it is not possible. Why so? Because this electron don't have sufficient electric energy, sufficient energy to jump into this at room temperature. Similarly, this hole doesn't have sufficient energy to jump and recombining with electron in this region. So, now this region acts as a barrier here. This is considered as barrier voltage. Okay. Now this barrier voltage had some value. For silicon, this barrier voltage is 0.7 volt, and for germanium, this barrier voltage is 0.3 volts. So this is the basic structure of what a PN junction is and how it works. Here, two, three things we will mention. First is depletion layer. What are depletion layer? Electron and hole are diffusing inside, diffusing and recombining with each other and making a neutral charge. And this neutral charge is nothing but an empty strip, which is called as depletion layer. Well, all electrons depleted the holes fully. Now, if the depletion occur, then if the loss of electron in n side here, so a positive polarity of charge will attract in this side, and if the loss of hole is there, so negative charge polarity is attracted this side. So due to this positive and negative charge, an electric field will create from positive to negative, or this electric field is nothing but creating a voltage barrier here. So this barrier voltage is nothing but E into D. D is the difference between the plate. Okay, now this is the basic structure of p-n junction. Now, let me ask you one question here. If these electrons are not moving and jumping here, not jumping here, and these holes are not jumping here, so what is the meaning? No current is flowing here. Why we study this junction? No, it's not true. We will study this junction. Why so? Because we bias this junction. So here the need of biasing comes. We have to bias this junction with some voltage. As we know, active and passive, and PN junction is PN junction diodes, which are majorly active components. So active component need a biasing voltage. So here the term biasing comes. Why so? Because if I have to start working with this diode or a junction, I need to give a particular operating voltage to that. So this barrier will, remove, and the electron and holes start flowing and take part in conduction. Let us discuss biasing here. First, we will discuss forward biasing or FB. Now, what is happening in forward bias? Let's consider this PN junction. So in forward bias, we are connecting the P side to positive terminal of the battery and N side to the negative terminal of the battery. So we know that P side majority charge carrier is hole, which is positive, N side negative charge carrier, which are electron in majority. So these charge repel each other. This negative negative repel each other, this positive positive repel each other. So what will happen? This positive charge try to move into this direction, and this negative charge try to move into this direction. So here what we discuss here, a depletion region is there. So that this depletion region make thinner due to the process of biasing. When we apply biasing, the width of the depletion region will decrease to a certain level. So if this is decreased, then the conduction start and the diode start working. So this is the basic structure of what a simple biasing means. Let me draw it again. So this is the PN junction, and here P side to, and here P side to positive terminal, N side to negative terminal, and the current start flowing in this direction. Okay, now if I talk about this width with you, in heavily doped junction, the junction which is heavily doped, the width is little thinner, and if the junction is lightly doped, the width is little wide. So this need to be considered. In heavily doped junction, this is thin, and in lightly doped junction, this is wide. This layer is wide, which is depletion layer. So this is the condition of forward bias. Now we will discuss forward bias VI characteristics, that how current and voltages are related in forward bias. Voltage, and this is current. Now let us consider this 1 volt, and here somewhere 0 volt, and here in between 0.7 volt. Let's say if I talk about silicon. So if I talk about silicon, we know that we need 0.7 volt to make start flow conduction, and the depletion region will start flow conduction. So till 0.7 volt, the current is negligible, and after 0.7 volt, current will increase exponentially. So this is the VI characteristics of what we are having in forward bias. So this is the basic phenomena what we are doing in a forward bias. So if I talk about PN junction diodes, so diodes, in PN junction diodes, they only work in forward bias conditions. In reverse bias condition, the two other mechanisms which are breakdown system are there, which will follow, which we discuss in our next class. So for today, this is much. Thank you all.